Okay, so we're going to continue working through some problems. Here we're given another function that is in terms of x and y where we cannot isolate x or y. So here it says evaluate dy dx at x equals 1. And what this means is find the slope. We want to find the slope at x equals 1. Okay, and there's a note here that says if you only need to find the numerical value of the derivative, you don't need to solve for dy dx. We can substitute in our x and y values. So in this case, what I need to do first is I need to take the derivative. So I'm going to take the derivative right here. So when we take the derivative, this becomes 6x squared dx dx, which cancels out, plus 2y dy dx is equal to 3 dy dx. Okay, I don't need to solve for dy dx because all I'm doing is trying to find the slope. But what I do need to do, because my derivative is all in terms of x's and y's, I need to solve for my y value, which means I need to go over here, take this function 2x cubed plus y squared is equal to 3y, and I need to plug in when x is equal to 1. So I'm going to find y. So I'm going to plug in x. So this is 2 times 1 cubed plus y squared is equal to 3y. This is going to be a quadratic, which means I need to move this over here and set it equal to 0, put it in standard form. So this is y squared minus 3y plus 2 is equal to 0. So that means I need to factor. So my two factors are y minus 2, y plus 1, or excuse me, y minus 2, y minus 1 is equal to 0. So that means I actually have 2 points on the graph where x is equal to 1. So I need to find two slopes. So I have the point 1, 1, that comes from here, and the point 1, 2. So we're going to find two slopes. So when the point is 1, 1, I'm using this 6x squared plus 2y dy dx, which represents the slope, is equal to 3 dy dx. So I'm going to plug in my x and my y value. So we have 6 times 1 squared plus 2 times 1 dy dx is equal to 3 dy dx. So this is like a variable. This just becomes 6 plus 2 dy dx is equal to 3 dy dx. To solve for dy dx, I need to subtract this whole term. So we end up with 6 is equal to dy dx because 3 minus 2 is 1. So this is your slope when you are at the point 1, 1. So this is the first one. We need to find the second one when the point is 1, 2. Okay, so I'm going to go over here, point 1, 2. Using this right here, I will plug in. So we have 6x squared plus 2y dy dx is equal to 3 dy dx. So in this case, we're plugging in the point 1, 2. So 1 squared is 1, so this is 6 plus 2 times 2 dy dx is equal to 3 dy dx. This is essentially the same thing. So we have 4 dy dx, and we're going to subtract and move over here. So 6 is equal to negative dy dx. So that means the slope, dy dx, is equal to negative 6 at the point 1, 2. Okay, so we found the slope at x equals 1. 1 occurred twice for x on this graph. So you're done. These are your two answers. This whole problem is actually related. Here we want to find the equations of the tangent line at x equals 1. Find the equations of the tangent line. So what this means is I need to use those slopes and use the equation y minus y sub 1 is equal to m times x minus x sub 1. Okay, so we have the slope is 6 at 1, 1. So for the first scenario, I'll put it like this. We have m is equal to 6. At the point 1, 1, we have all the information that we need, so let's plug into the formula. So this would be y minus 1 is equal to 6 times x minus 1. You're done. The second one, which is at the point 1, 2, my slope is negative 6 at 1, 2. You have y minus 2, which is right here, is equal to negative 6 times x minus 1. So these are your two equations of the tangent line to this curve. Okay. Here it says find the equations of the normal line. So what does it mean when the line is normal to or at x equals 1? What this means right here is we are looking for the perpendicular line. Okay? So at the point 1, 1, okay, remember you have a slope of 6. We found that up here in part A. But we want the perpendicular line at that point, which means I need to find the opposite reciprocal. So the perpendicular slope is equal to negative 1 over 6. I have the point, I have the slope. I want to use this slope here because we're looking for the perpendicular line. So we have y minus 1 is equal to negative 1/6 times x minus 1. Again, this is about vocabulary and understanding what they're looking for. So then we still have the other point, 1, 2. There we had a slope of negative 6. So the perpendicular slope is equal to positive 1 over 6 because we took the negative reciprocal. So again, we are looking at this slope and this point. Okay, we don't care about this slope anymore. Y minus 2 is equal to 1/6 times x minus 1, and you're done. This is an equation of a line that is tangent to the curve, both of these. These two are perpendicular at x equals 1. Okay, in part D, it says right here, find all points on the graph. Points means xy, so we need an x comma y on the graph at which the tangent line is horizontal. So what this means, even though it tells you, we want a slope of 0. Okay, so first of all, what's going to happen here is, if I go back up to the top, and I'm going to use this space right here to do it, so let me separate this. I'm taking this function 6x squared plus 2y dy dx is equal to 3 dy dx, and I need to solve for dy dx, okay, because now this is asking me about the slope specifically. So what I need to do is solve for dy dx. So that means I need to get any term with dy dx on one side. So I'm going to subtract this. This should be minus, not equals, minus 2y dy dx. And now what I can do is factor this out. Okay, so I'm going to do this right here. So we have 6x squared is equal to dy dx times 3 minus 2y. To solve for dy dx, I need to divide by this. So I'm going to put this down here. So we have dy dx is equal to 6x squared over 3 minus 2y. Okay, so I solved this because I wanted to point out what this is saying. If we are looking for the tangent line, or the points at which the tangent line is horizontal, that means we know that the slope is equal to 0, which is essentially 0 over 1. So when you have a rational function like this, and you have a variable in the denominator, this is still saying that the slope is 1, but I'm writing it as a fraction. So what I'm going to do is cross multiply. When I cross multiply, 3 minus 2i times 0 is 0. So then I'm left with 6x squared is equal to 0. Okay, so what I want are the points. So in this case, when I solve for x by dividing by 6 and taking the square root, it's still going to be 0. So x is 0. I have my x value, so what I need is my y value. So I actually need to go back to the original function. So to find y, you go back to the original. So in this case, the original function's all the way at the top. It's this one right here. Okay? So I've got 2x cubed plus y squared is equal to 3y. We're going to plug in 0 for x and solve for y. So when I plug in 0 for x, this goes away. Because I need to solve for y, that means I need to move this over to the other side, subtracting 3y and setting my equation equal to 0. So we have y squared minus 3y is equal to 0. This I can factor. So when I factor, it turns out I actually have two y values when x is 0. So we have y times y minus 3 is equal to 0. When I solve each factor for y is equal to 0 and y is equal to 3. So the points written as coordinates would be the x value of 0, the y value of 0, then the x value of 0, and the y value of 3. So this is where we have horizontal tangent lines. There's 2 points where that occurs. This last problem right here says find all points on the graph where the tangent line is vertical. Okay, and if you have a vertical tangent line, okay, that means your line on the graph is like this. So the slope here would be undefined, which essentially would be the same thing. If the slope here is 0 for a horizontal tangent line, that means it's 0 over 1. That means that these are flipped, because if you have a horizontal line and you flip it, it becomes vertical. When I flip this slope over, it's 1 over 0. I'm only writing it like this because I just want to show you that this is essentially the same thing that you're working with. So here, what we want to do is take your slope of dy dx being equal to 6x squared over 3 minus 2y. Because we want a vertical tangent line, what we're looking for is where the slope is undefined. So I'm going to set this equal to 1 over 0. You're going to cross multiply, just like we did up here. One of these is going to go away. When I cross multiply this way, my numerator goes away, and I have my denominator that I'm going to set equal to 0. So here, we have 3 minus 2y is equal to 0. So in this case, when we're solving for the point or points, okay, we want the points, okay, we're solving for our y value first. I still have to go back to the original equation, but now in that case, I'll be solving for x. So I would add 2y and divide by 2. So unfortunately, I get a fraction, but should be okay. So we have y is equal to 3/2. So then I'm going to go back to my original equation of 2x cubed plus y squared is equal to 3y and plug in my y value. So we have 2x cubed plus 3/2 squared is equal to 3 times 3/2. 2x cubed plus 9/4 is equal to 9/2. So I need to move this over here, so I need a common denominator. So I'm going to multiply this by 2 over 2. So this is 18/4. 2x cubed is equal to 18/4 minus 9/4 is 9/4. I don't know why I wrote that as a fraction. 2x cubed. Okay? So now I need to solve for x. So then divide by 2 or multiply by 1/2. So we have x cubed is equal to 9/4 times 1/2. So this is 9/8. And we're going to take the cube root. So x is equal to the cube root of 9, because that's not a perfect cube, over 2. So that means I actually only have one point where I have a vertical tangent line, and it's at the point, the cubed root of 9 over 2, 3/2. It doesn't matter what that value is, just leave it. It's fine. In this last problem, you might need a little bit more room because this is a little bit different than what you've seen before. So I'm actually going to do this on a separate sheet of paper. So we have the function that we want to find the second derivative of. Okay, and this is 4x squared minus 2y squared is equal to 9. So in order to find the second derivative, what I actually need to do, obviously, is find the first derivative and solve for dy dx. So when I take the first derivative, this becomes 8x minus 4y dy dx is equal to 0. Remember, the derivative of a constant is 0. Move this over here. So we have 8x is equal to 4y dy dx. Divide by 4y and simplify, so this becomes 2x over y is equal to dy dx. Okay, so this is my first derivative, and this is important to remember because I might need this later. So what I want to do now is actually use the quotient rule, so I'm going to create this table. I have f is equal to 2x, so f prime is equal to 2. g is equal to y, so g prime is dy dx. Keep that in mind because we're going to need this later. So then the second derivative is equal to, using the quotient rule, we've got f prime times g, so that leaves me with 2y minus f g prime 2x dy dx over g squared. Okay, so now what happens is I know what dy dx is. You cannot have one derivative in terms of another, so we need to make a substitution. So what we want to do is take what we know up here and substitute right here. Okay, so we've got 2y minus 2x, and now we're going to make this substitution of 2x over y all over y squared. So now we're going to multiply and try to start simplifying here. So we've got 2y minus 4x squared over y all over y squared. This is a complex fraction, so we need to multiply by the least common denominator. So that gives me 2y squared when I distribute, minus, this goes away, over y cubed. At this point, this is essentially your answer. However, something that you need to make note of is we have seen this before, and if you were looking at this in an AP practice, 2y squared minus 4x squared, if you go up to the top, okay, you actually see that this is the same thing but exact opposites. So essentially what this is equal to is -9. It is the exact opposite, because if I were to multiply this whole thing by a -1, you are left with 2y squared minus 4x squared is equal to -9, which then takes you back down to the bottom. So you do need to make that substitution. So this is actually -9 over y cubed, which is the second derivative. This would be something that you could see in an AP practice, and you need to understand how to simplify. The biggest thing that you need to take away from this, though, is when you are asked to take the second derivative and you are deriving implicitly, you have to make the substitution for dy dx. You cannot leave this in terms of dy dx. You have to simplify. So that's why I highlighted this here.